Hi guys, Bob Murphy again, welcome. We're now going to talk a little bit about something called Dalton's law. You haven't got to know the name of the law. That partial pressure. Why is this important to you? It's important to you because, hey, maybe you are a nitrox diver already, or you're going to be a nitrox diver. Yeah? Those guys are limited in their depth because of partial pressure. They're actually limited by the elevated oxygen. Yeah? If you are very unlucky to get a bad tank, it's very important to understand this, yeah? Because this is what is going to cause your problem with a small amount of contaminants in your tank. Yeah? And if you're fortunate enough to go technical diving, also it's this that governs how narked you get when you go deep. Yeah? So it's nice stuff to know. Yeah? So let's start off very easy. Let's start off with what we have right here. Yeah, my 1 atmosphere. So I'm at sea level. Yeah. So I'll put the sea here. I'll say, right, I'm at 1 atmosphere. And what Dalton said was, he said, hey, the gases that are exerting a pressure on me right now, yeah, each of them exerts its own pressure. So of that 1 atmosphere, for our purposes in this lesson, we only have 2 gases that we're concerned with, okay? We're concerned with oxygen and nitrogen. And I think you all know that 21% of our atmosphere approximately is oxygen, and 79, the remainder approximately, is nitrogen. Yeah? What this guy said, he said, hey, the pressure exerted on you, 21% of that pressure right now is due to that oxygen, and 79% of that pressure right now is due to nitrogen. Yeah. So, well, what is the answer? Well, I don't work in percentages. Well, most of us have been working in percentages all of our lives. And when I said to you, look, here's $1. Yeah. And I said to you, hey, what's 21% of $1? You can probably all answer me. Yeah? But if you can't answer me, or you don't like percentages, you press $1. You can even put the 00 in if you like. $1, yeah, times 21, and press the percent button. And it says 0.21. 0.21. Don't I know, oh my God, what is 0.21? It's dollars. Yeah. So 21% of $1, yeah, is in your mind 21 cents or $0.21. The same is true here. Yeah. So if you're unhappy with percentages, think about it. You've been using them probably most of your adult life. So now, by the same token, now 21% of, not $1, 1 atmosphere, is how much pressure the oxygen is exerting on me. So I say, hey, let's go again. 1.00, 1 atmosphere, or just 1, times 21%, again, is 0.21. So I have 0.21 atmospheres, not dollars. And that is, the way we write that is, I write it PPO2, partial pressure oxygen. Yeah? And if I do the same thing for the nitrogen, 1 times 79%, and you must do it that way round, I get 0.79. So consequently I have 0.79 atmospheres partial pressure nitrogen. Happy with that? Let's take it somewhere nice and easy then. Let's take it down to 2 atmospheres, 10 meters. I have the same gas. Let's do the same calculation, and I've still got 21%, but suddenly now I haven't got 1 atmosphere. I've got 2 atmospheres, so now I go 2. That's the atmosphere I've got. 2 times 21, press the percent key. 0.42. Okay then. So now I have 0.42 atmospheres partial pressure oxygen. And I think most of you can see the partial pressure has doubled because the pressure has doubled. Yeah. I want to do the same thing with the nitrogen. I've got 2 atmospheres again, just like my dollars, 2 times 79%. Okay, so I've got 1.58 atmospheres partial pressure nitrogen. And if you add these 2 numbers up, you'll see a total 2. The total pressure is 2, and it's made up of these 2 pressures. Parts of that pressure, partial pressure. If you add up these 2, 0.21, 0.79, they make up 1 atmosphere. That's the way that partial pressures work. Now you can take this absolutely anywhere. Using basic calculator skills, you can say, hey, I'm going technical diving. I want to go to 48 meters. Sorry, I did neglect to say we were in seawater, which I know from this calculation is 5.8 atmospheres. Cool. I'm still breathing air. Let's see how good this is. Okay, so I'm at 5.8 atmospheres. 5.8 times 21, press the percent key, 1.218. So I have 1.218 atmospheres partial pressure oxygen. Okay. Let's do the nitrogen. Here. 5.8 times 79%. I've got 4.582 atmospheres. 4.582 atmospheres partial pressure nitrogen. Now look at those 2 numbers there. This number here, for those of you that are nitrox divers, this number has a limit, safety limit when we nitrox dive of 1.4, and you can see we're well beyond normal recreational diving here, so we're not diving nitrox here. Now we're diving air. Now, this number here, that's the number that causes your narcosis. And I've definitely got narcosis at 48 meters. Okay, let's change the gas. If you want to screenshot that, you're welcome to. But we're going to change gases now because that's where partial pressure comes in to its own a little bit. Okay, so I'll take all these away, take the C away, and take the air away. Okay, cool. Now I'm going to go diving. I'm going to go diving with this tank here. Nitrox diving. 36% is oxygen and 64% is nitrogen. Cool. So if we use exactly the same mathematics, we can take this anywhere. So we go 1 times 36%, 0.36, I think you probably all had that on the surface. 0.36 atmospheres. Okay. And my partial pressure nitrogen, I've written this the other way around now, it doesn't make a difference, it's still very, very clear. So I go, okay then, 1 times, and the remaining 64% is a 0.64. No surprise there. Cool. Let's take this one underwater. And let's take this one underwater. First we'll take it to 20 meters. And using this calculation here, that is 3 atmospheres. And I want to know the partial pressure oxygen and the partial pressure nitrogen. Cool. all the information I need is on my drawing. I would suggest you draw something similar in your exams. You can always check back in yourself. Okay, so clear my calculator. 3 atmospheres times, I'm diving 36%, so my partial pressure oxygen 36%, 1.08 atmospheres. And my partial pressure nitrogen is actually the remainder, but we'll do it anyway. I go 3 atmospheres times 79%, and that says 2.37. I've done that wrong. Oh, 79, sorry. My mistake. Three atmospheres times 64%. We all make mistakes. 1.92. 1.92 atmospheres. Cool, and you can see, that's why I realised I made my mistake when the two didn't add up. Okay. So now, you can see that this number here, diving nitrox, this number's getting quite high now. So now you'll find that if I take this to the next depth, 30 meters, 4 atmospheres, and we do the same calculation, I'll write in partial pressure oxygen equals, so 4 atmospheres, 4 times 36%, oh, and it comes up with 1.44 atmospheres. And if you guys who are nitrox divers out there, you know that this is a no-no beyond 1.4. Yeah? So what we have to do about that is we have to work out what our maximum depth is, and that's a different calculation altogether. You can see 30 meters is too deep for this particular tank. Okay, let's look at one other situation in which partial pressure becomes important. Let's take rub it out. Let's take a dirty tank, shall we? And in this tank, we don't care about the oxygen and nitrogen in this stage. In this tank here, we care about the bad gas. And that gas is carbon monoxide. Something we don't like as divers. Carbon monoxide comes from car exhausts, burning of fossil fuels. Carbon monoxide is a dangerous gas. But in small percentages, it's not so bad. Unfortunately, our body responds to partial pressures, not percentages. So the effect of this gas is going to increase as we take it underwater. So if we look at the partial pressure, and carbon monoxide's chemical symbol is CO, 1 carbon, 1 oxygen, then we do 1 atmosphere, which is what I've got up here, times 1%, which is my carbon monoxide. I've got 0.01, that's fairly obvious, is 0.01 atmospheres. Now I'm not happy about that 1% of carbon monoxide, but it's not going to kill me. As I take this down, suddenly the partial pressure carbon monoxide, the second situation in which we're worrying about it, I've got 2 atmospheres, breathing 1%. I think it's fairly obvious what's going to happen here. 2 times 1%, 0.02. Yeah. Atmospheres, and I think it's very obvious, 0.03. Atmospheres, 0.04 atmospheres. As you can see, the effect of the partial pressure is the effect. So the effect of the gas has doubled, trebled, quadrupled. So down here I'm reacting to a partial pressure of 0.04. This is hazardous. Okay. Sometimes your question will ask you, that would be the equivalent of reading what on a surface. And what they mean by that is, how could you achieve this partial pressure if you were standing up here? How would you achieve 0.04 atmospheres standing up here? Oh, you quite simply put 4% in the tank. Now, if you understand that, fantastic. If you don't understand, please say something in the messages below, and I'll try and clarify a little more for you. I'll make another video.